Welcome to the deep dive. We've gathered quite a stack of sources today. We're focusing on a really interesting discussion from IBM Technologies' YouTube channel, all about the latest in AI and, yeah, quantum computing too.
Right. And our mission here really is to cut through all the noise. We want to pull out the most important bits, the actual nuggets from what companies like Apple, OpenAI, Meta, Scale AI, and IBM Quantum have been up to recently.
Think of it as a quick way for you to get informed on the key moves, where they're placing their bets, and what actually matters.
Exactly. So what's on the docket?
Okay, so we'll kick off with Apple's WWDC, their whole approach to AI, which seems, well, cautious but maybe strategic. Then we'll look at OpenAI, their new model, O3 Pro, and Sam Altman's essay that's got people talking.
A gentle singularity, yeah. Interesting framing.
Then a huge deal, Meta and Scale AI, which really puts the spotlight on the infrastructure side of things, often overlooked.
Definitely. And finally, some genuinely compelling news from IBM Quantum. Seems they're making real strides on fault tolerance.
So let's unpack it all.
Sounds good. A real mix of computation's future from different angles.
All right, first up, Apple's WWDC. Initial reactions we saw in the sources were, well, let's just say a bit spicy.
Huh, yeah. Some were quite critical. You saw things like renaming the event, why was design changed. Someone even called the new Liquid Glass OS design Apple's Windows Vista moment. Ouch.
Yeah, that's harsh. And the interesting critique was one observer pointed out the glass design maybe wasn't quite ready, but Apple shipped it anyway.
Right. But then lots of AI features are being held back because they're not quite ready. So the source was kind of like, come on, Apple, pick a lane.
And meanwhile, we get an even darker dark mode, the crucial stuff. But seriously, the underlying tension is that huge competitive pressure in AI. OpenAI, Meta, Google, Samsung, they're all pushing hard.
Apple's seen as a late AI entry by many.
Which leads right to that question from the source. What about the OpenAI partnership? Did it really move things forward, or did it just maybe highlight where Apple might be lagging a bit?
Especially when you compare it to Meta's Llama or Google's Gemini. There was definitely a sense of disappointment around the Siri overhaul, wasn't there? It felt like Apple was still lagging behind the competition on those core AI capabilities people hoped for.
But, okay, here's the flip side. The potential Apple strategy. Even if they are behind on the absolute cutting-edge models, the sources hammered home Apple's massive unfair advantage.
Their ecosystem and their hardware.
Exactly. That's the key differentiator, right? Everyone agrees Apple Silicon is just incredible.
Phenomenal hardware. And the potential play here is using that hardware to run LLMs, the large language models, directly on the device.
Like a framework. So developers use SDKs, maybe, instead of every app trying to cram in its own little model?
Precisely. Avoids inefficiency. And think about Apple Intelligence interacting with what's actually on your screen. That's a powerful integration point.
So the thinking is, Apple might be kind of admitting, look, we're not necessarily going to win the model arms race.
But we can open up totally new ways for AI to work across all our stuff. New surfaces, new interactions.
Which, one source said pretty bluntly, might be their only play left, especially if earlier internal AI projects weren't quite prime-time ready.
So yeah, you get incremental stuff, changing wallpapers in iMessage. Okay. But the feeling was the real intelligence leap wasn't quite there yet. At least not in what they showed off.
But let's circle back to that unfair advantage, because it's not just the silicon, it's trust, isn't it?
Huge. People trust Apple with really personal stuff. Parental controls, security, kids access.
Which means users might be way more comfortable with Apple delivering truly personalized AI experiences than they would be with, say, a third party.
Absolutely. Both Google and Apple, because they hold that user data, have this extraordinary opportunity to hyper-personalize intelligence.
And that's why it's so striking when critics say Apple's AI progress feels underwhelming, despite having that incredible hardware and that deep user trust.
The speculation is they're just being very cautious or maybe very conservative,
Yeah.
really leaning into that privacy-first approach,
Yeah.
which is good. But maybe it slows down the flashy feature rollout.
Yeah, someone even brought up that daring fireball narrative about Google maybe a year ago, how Google had all the pieces but wasn't quite crushing it. Is Apple in a similar spot now? A holding pattern?
It does make you wonder if it's a longer game.
Yeah.
Is Apple mostly just setting themselves up for the future at a platform level
How so?
by, unifying the devices, making the iPad more Mac-like, the Mac more iPhone-like, building that consistent design system, the liquid glass thing across everything,
Yeah.
the AI layer, just sits neatly on top of that unified platform eventually.
And they can afford it, right? Their position means they can get it wrong for a very long time before they get it right and still largely be okay.
Exactly. So maybe what looks like lagging is actually just deliberate, cautious platform building. Quite a contrast, perhaps, to OpenAI.
Perfect segue. Let's switch over to OpenAI. Two big things recently, O3 Pro, their new model, and Sam Altman's essay, The Gentle Singularity.
Right. O3 Pro, pitched as a more advanced reasoning model. I mean, it tweaks pricing, too, making some existing models cheaper, more accessible.
And Altman's essay, it's pretty bold, arguing we're already living through the singularity, not some big future event, but happening now, that the world's going to feel very different over the next decade because of it.
Initial reactions to O3 Pro itself, the sources highlighted a lot of advanced features, especially around reasoning and multimodality.
And here's a fascinating link back to Apple, that illusion of thinking paper they put out.
Oh, yeah, the test. Apparently, O3 Pro was given the exact Tower of Hanoi problem from that Apple paper.
Yeah, my.
And it just crushed it right away. So the implication from OpenAI, maybe not said out loud, but definitely felt, was kind of like, look, stop making excuses. AI is working really, really well in these kinds of reasoning tasks.
Okay, so that's the tech. What about Altman's gentle singularity essay? Some found it overly optimistic, right?
Yeah, that framing gentle, where AI is just this helpful assistant helping you solve hard problems. It was seen as a smart narrative shift. Moves away from the whole machines taking over trope.
Make it sound less threatening. And he talks about the potential upsides, reshaping science, economics, education.
But the conversation in our sources immediately jumped to the counterpoints, the challenges that aren't so gentle.
Like what?
Well, misalignment, for one. Does the AI actually do what we intend? The impact on jobs, obviously a big one. And a really crucial point, unequal access. Democratization.
Ah, so who actually benefits?
Exactly. Could it worsen global divides?
Yeah.
Who gets access? Does it privilege certain people or certain nations? These are seen as much deeper, trickier issues than the maybe nice and utopic vision presented in the essay.
And from a business angle, while O3 Pro sounds amazing, the point was made that companies are already getting an insane amount of value from current AI.
Right. ROI-driven intelligence.
Yeah.
AI that actually shows a return. That's key right now for many organizations.
So it's like needing a hierarchy of intelligence.
Yeah, exactly. Different tools for different jobs, maybe a small model that went to a community college for basic accounting, but you need the PhD level O3 Pro for, I don't know, complex strategic planning. Different needs, different price points.
Let's circle back to that Apple illusion of thinking paper again, especially now knowing how O3 Pro handled its test. The paper basically challenged whether current models can really reason.
It did. But O3 Pro acing their own challenge kind of suggests Apple might be just wrong in what they're arguing, or at least their specific test wasn't the slam dunk they thought.
Though apparently O3 Pro itself pointed out some issues with the paper's method, like using just one prompting strategy.
Yeah, there was some skepticism about the methodology reported.
Yeah.
But to be fair, the source discussion did acknowledge the Apple paper had some valid points.
Such as?
Well, using puzzles is important to try and separate rote regurgitation from something more like true thinking, especially with model contamination being a potential issue.
And the idea that models might just collapse in and of itself during really long reasoning tasks, especially if they can't use tools or get fresh info.
That's a recognized potential weakness, sure. But the pragmatic counter was, okay, call it simulation, call it copying, call it pattern matching. If it's able to do the tasks that I wanted to do, then it's valuable.
The capability matters more than the label of reasoning for a lot of people.
Pretty much. The semantics can be debated forever.
Someone even half-joked about AI rights, saying we shouldn't hold AI to a higher standard than humans, like demanding 95% accuracy when we hire people who are far from perfect.
Yeah. The point being, appreciate his strengths, understand his weaknesses, assign work accordingly. Don't expect it to be a perfect human.
Which leads to needing different sizes of models too, right? Like 70 billion parameter models for complex orchestration tasks and multi-agent setups.
Exactly. Those bigger models can better influence the reasoning model to do things a certain way, but the smaller ones are getting better fast too.
So it's this ongoing tension, battle between pragmatism, does it work, versus the deeper scientific need to know what it's actually doing.
A classic AI debate. And OpenAI, clearly pushing hard on the does it work side, while definitely stirring up the conversation about what working really means.
Okay, let's pivot from theory and capability to Well, raw power and money. The business side, that huge $15 billion transaction between Meta and Scale AI. Scale AI, the data annotation folks.
Yeah, that number really jumps out. Just shows how the price tags in AI are getting bigger and bigger.
And the obvious question the sources asked was, why? Why is Meta dropping $15 billion on this particular company?
The main take is pretty straightforward. Meta wants to get ahead in the AI race. Simple as that. They're up against Anthropic, Google, OpenAI. Even with good models like Llama, the competition is intense.
So this is another bet in the ring, maybe setting up a parallel track, a dedicated lag for superintelligence separate from day-to-day products.
Could be. It signals how fierce that competition is, requiring massive spending just to stay in the game.
And there was a quick clarification about Scale AI's founder, Alexander Wang. He's not just some random tech guy.
Oh no. The source corrected that, called him a math prodigy, coding genius. Serious street cred apparently comes from a very talented family, so getting him personally was likely a huge part of the deal.
Makes sense. And Scale AI itself has phenomenal assets, right? Really good at creating synthetic data, prepping data for training.
And there aren't many others doing it at their scale or quality, so yeah, it looks very much like an acqui-hire. Maybe the only way Meta could bring Wang into the fold.
Which is interesting because Meta doesn't usually bring outsiders into super senior roles like this, does it? Suggests they felt a real need to shake things up.
Yeah, it's a notable move. And if you place Meta on that spectrum, we talked about Apple being cautious, OpenAI pushing boundaries. Meta seems somewhere in the middle. They're trying to figure out which side should I go, and basically decided to go follow where the market is going.
Which means spending big. And put that $15 billion in context. It's just part of Meta's total capital expenditure plan for the year. Their CapEx commitment is like $60–70 billion.
Whoa, so they're seriously doubling down, trying to match the infrastructure spending of AWS and Microsoft.
It shows companies are getting very, very creative now with talent, IP, data, how they acquire what they need. Scale AI seems like a really, really good acquisition for Meta's data pipeline.
Especially since, as the sources reiterated, people are still waiting for a really good reasoning model from Meta. This deal shores up a absolutely critical foundation for building those models.
So the big takeaway here is
Infrastructure matters as much as models, training, data evaluation, human feedback. The algorithms are only part of it. The AI wars are being fought right now on the infrastructure battleground.
meaning controlling the data flow, the chips, the data centers. That underlying stuff is becoming as important as, if not even more important than just developing the new models.
Exactly. This investment secures Meta's foundational AI supply chain. It's a massive bet on their AGI ambitions, strengthening the very base they need to build upon.
Huge move, focusing on the nuts and bolts. Okay, last segment. Let's shift gears a bit away from pure AI, though these fields are getting tangled. We're diving into quantum computing, specifically some really exciting updates from IBM based on insights from their quantum CTO, Oliver Dial, from our source material.
Yeah, it's easy for a quantum to get lost with all the AI hype, but the source really stressed that some really exciting things happening there
Well,
lately.
despite all the skepticism, right? You always hear quantum is never going to happen, or people have been talking about quantum forever.
Right. But the counter-argument, which sounded pretty convincing, is that in just the last, say, 24 months, there have been really kind of major leaps. Things that make practical quantum computing feel much closer, like around the corner.
They even predicted quantum advantage, a quantum computer doing something better than classical by the 2026, maybe even sooner.
That's the timeline being discussed now. And a huge piece of that puzzle is fault tolerance, which has always been the monster problem.
Why is it so hard?
Well, because you're dealing with some of the most sensitive systems imaginable, manipulating single quantum states, qubits. The current error rates are just orders of magnitude worse than classical computers.
Like how bad?
Maybe a 1 in 1,000 chance of an error for a basic 2-qubit operation. Compare that to, I don't know, 1 in a trillion for a transistor. It's a different world.
And the errors come from fragility.
Exactly. Any tiny bit of environmental interference, stray microwave energy, which is how they control the qubits, can flip a state. Even microscopic stuff, contaminants on the chip surface. It's incredibly delicate.
So the current approach, this era of utility, basically involves just running things over and over.
Pretty much.
Yeah.
Run the computation many, many times, then use statistics to average out the noise, remove the errors, and hopefully get an accurate answer.
Yeah.
That's how they're tackling small problems now. Chemistry, optimization, materials, showing that near-term potential.
But the limitation is
That overhead, the extra work needed for denoising, it scales exponentially with the size of the problem. So for bigger problems, it becomes a little bit of in the long term, a losing proposition.
Yeah.
The error correction itself becomes the bottleneck.
Okay, so that's where true fault tolerance comes in, using error correction codes.
Right. A different bag of tricks. Think kind of like parity bits in classical memory,
Yeah.
but way more complex. You use extra qubits to constantly check for and correct errors on the fly as you do the computation before they build up.
And the big win is that the overhead for this kind of error correction is no longer exponential.
That's the crucial part. If you can do this efficiently, it opens the path to scaling up,
Yeah.
doing much larger computations.
Yeah.
But the type of error correction code you use makes a huge difference.
People talk about the surface code a lot.
Yeah, it's well known. Simple layout like a checkerboard or a square lattice only needs nearest neighbor connections between qubits. That's good for manufacturing, relatively easy to build. The efficiency is terrible. To get just one good error-corrected logical qubit using the surface code, you might need thousands or tens of thousands of physical qubits.
And we only have devices with around 1,000 physical qubits today.
Exactly. So the surface code, while conceptually neat, is just not practical right now. Too expensive, it's too large.
Okay, so this brings us to IBM's big news, the gross code. They're calling it the dozen code, a distance 10 code.
Right. The key thing is it breaks that simple checkerboard layout. It needs 2 long-range connections for each qubit, like little highway overpasses across the chip.
More complex to build, presumably.
Yes, but the payoff is huge efficiency. With just 300 physical qubits, we can encode 12 logical qubits. That's an order of magnitude fewer qubits than the surface code needs for similar performance.
Wow. So the benefit isn't just correcting errors, it's doing it way more efficiently, and it exponentiates your error rate. What does that mean?
It means it takes the underlying error rate of your physical qubit, say, the 1 in 1,000, and effectively raises it to a high power based on the code's properties. It gives you this enormous lever arm to suppress errors on the logical qubits you actually compute with.
So you still need better hardware, but this code makes practical fault tolerance achievable much sooner with fewer qubits.
That's the idea. It makes the goal reachable.
And what kind of problems does this unlock?
Well, moving from today's small chemistry problems to really complex chemistry problems in catalysis and organic chemistry. Material science, designing superconductors, finding exotic states of matter.
What about optimization? That seems like a big application area.
Definitely. It excites clients the most, apparently. But it needs a wider logical register, more of those good logical qubits working together. Think complex logistics for financial institutions or logistics companies. Maybe not the simple traveling salesman example, but real, messy, large-scale optimization.
Okay, but the big question remains, why believe you guys that this time is different? What's the key?
Modularity. That's the key reason given. You can't build these massive, complex machines monolithically. You need smaller, reliable unit cells you can build, test individually, and then connect.
And the gross code's module size is?
Pretty small. Yeah, around 500 qubits for a fundamental module.
So that brings fault tolerance into reach. You don't need to build one perfect under 1,000 qubit chip. You build lots of reliable 500 qubit modules.
Exactly. Build the 500 qubit system, perfect the manufacturing, test it, then link them together.
And 500 qubits is feasible.
They say it's no bigger than what we built in the past, pointing to their 1,000 qubit Condor device. It's practical, and that's why they're building actual data centers now, like in Poughkeepsie, to house systems built this way.
So the takeaway is, the race to fault tolerance isn't science fiction anymore.
It feels like it's truly game on. Real engineering making it seem tangible.
Wow. Okay, what a range we covered. Apple playing the long game, maybe. Cautious, platform-first AI, leveraging that ecosystem trust, even if features felt a bit underwhelming to some critics.
Then OpenAI, just pushing the model capabilities hard, forcing us to rethink what AI can do, talking about this gentle singularity.
And Meta making that enormous infrastructure play with Scale AI, betting big on the foundational data layer, showing where a lot of the real AI battle is happening.
And finally, IBM making these very concrete modular steps towards practical, fault-tolerant quantum computers. A whole different computational paradigm taking shape.
It's fascinating seeing these parallel tracks. So here's a final thought for you to chew on. You've got these contrasting views on AI right now. Apple's apparent skepticism about reasoning versus OpenAI's models seemingly acing those kinds of tests. And at the same time, real progress towards powerful quantum machines. How might these very different paths, advanced AI and practical quantum, converge or maybe even compete to shape the whole future of computation and intelligence?
Yeah, that's a big question. Definitely something to think about.
Thanks for joining us for this deep dive.